Okay, one more definite integral with substitution, this time with good limits of integration. So I'm looking again for a composition and hopefully the derivative of the inner function showing up as well. So I have an x squared times e to the x cubed. The composition is the fact that e isn't just raised to the x, it's raised to the x cubed. So I would say x cubed is getting plugged into the exponential function, which means I want my w to be x cubed, and my dw dx would then be 3x squared, and I'm going to move the 3 over. dw over 3 is equal to x squared dx. Okay, so erasing, my x squared dx is going to become my dw, and I do have an over 3. I'm just going to move that out in front. That means that what I've done has changed the width of my rectangles. So I need to cut those and divide them by 3 basically. And then the e to the x cubed is going to become e to the w. And that at least is a nice easy one to find an antiderivative for. But we first need to deal with our limits of integration. And again, I'm really going to want to specifically see that you know that they change right now. So we're going to take our, oh, it's kind of boring in this one, but we're going to take our -1 and we're going to say, okay, when x is -1, what is w? -1 cubed is still -1. When x is 1, what is w? 1 cubed is still 1. So while it's not very impressive in this one, we did actually make a change. We figured out what our w's would have to start and stop at to be equivalent to our x's that we started and stopped at. So antiderivative of e to the w is still e to the w. Oops, 1/3, not 3. The 1/3 just carries through. And then we need to evaluate from -1 to 1. So no need to change back to x's here. We've already changed our limits of integration. So we just need to plug in 1/3 e to the 1 minus 1/3 e to the -1. And that would be our answer. Okay, so hopefully that gets you started. Let me know if you have any trouble with definite integrals. Thanks for watching.